So today we will, discuss what is that microcontroller, programming. Now, we should be knowing inside microcontroller. Okay, inside microcontroller. So there will be some memory. Okay, so there will be definitely there will be some memory. Okay, so this is the memory. Okay, and each memory has some, address. Okay, so as some address, and then it will be having some combinational circuit. Okay, so it will be having some, combinational circuit. So this is basically sequential circuit. Okay, so combinational circuit. You see, combinational circuit. Now, say for example, so this is basically some register. Okay, and I'll consider.
Sir, your screen is not visible, sir.
Yeah, yeah. Sorry. Yeah. So my screen is visible now.
Yes, sir.
Yeah. Okay. Now, what I'm discussing today is basically, in general, how this micro processor, okay, or microcontroller works. You know, that is what we are trying to discuss, and in that regard, so microprocessor and microcontroller definitely has some memory. Okay, so that is nothing but sequential circuit, and it will be having some combinational circuit. Okay, now this is just some empirical way of understanding microcontroller microprocessor, but we'll come to actual programming by taking some microprocessor like 8051, 8086, and ARM. Okay, ARM 7, something like that. So, but now just try to observe here. Okay, so now see, uh, memory, it has combinational circuit, is it has, and also some some general purpose register. Okay, say this is maybe register 1. Okay, register 2, and register 3. Okay, so maybe the register 3 is output register, register 1 2 maybe input register, maybe let us let me consider. Now I told let me add two number. Okay, so my objective is what, to add. Okay, so to add two number. Okay, to add two number. Okay, so two numbers. So this is the objective. So to add two number, let us see how how it works. Say for example, the two numbers may be present in some memory, say 20. Okay, now how we have to see, and inside this microcontroller definitely you will be having bidirectional data bus, and also you will be having address bus, address lines. Okay, so that is connected to all the registers and all the combinational circuit and all those things. This data bus and address bus will connect to all the element. Okay, so that is what you have to understand. Now, see, now I'm just writing some kind of some kind of I think some Microsoft one program is there for children. I don't know. Anybody remember that word, MS logo? Okay, what is that? For children, there is one programming is there in some fifth standard or something like that. No. What is that program name for children? Anybody remember? Or any? What is that program name? MSW logo. Yeah, this one. Okay. So this programming, this is for children's, you see, to understand the programming. Okay. So mostly for, uh, so fifth for, first fifth standard or fourth standard, they give this kind of, programming. Okay. So now you see in this program, if you take this example, you know, uh, you see, this is one, example. Now, this is the program. You know, what happens here? Go, 90-degree take shift, one step. Okay, forward 100 units. You see, forward 100 units, second step, and then again 90-degree turn. Okay, and move forward for 100 units. You see. So when you write a program, it creates some kind of, some kind of path. Okay. So they will understand the program also. You see. So there will be some instructions they will write using some instructions, some object, some, the drawing will be created. Okay, so some drawing will be created. So that is basically, they're trying to learn the program. Now you see in this, program, every step, means a lot. So similarly, let us, understand in that sense, step by step what happens in the microprocessor. Now, you see, now first is, I have to, first say I'm just writing one by one. Say pointer, you see, pointer should point to one. Okay, 0 1th address. You see, the address is now 0 1. Now I'm just writing the same terminology. So load address. Okay. So address is 10. Okay, then what you have to do? So data, okay. So data came to data bus, that is 20. Sorry, that is also 10, right? That is also 10. Sorry, address is 0 1. Na? Address is 0 1. Address is 0 1, correct? Data is 10. Okay. So then third step is, okay. So then the register. Okay, so store register with that particular data. Register 1 is equal to the 10. So fourth step, then change the address to, so address is equal to 02. Okay, address is equal to 02. You see, I'm just writing some kind of MSW Pogo. Okay, so address data is now, okay, data is equal to 20. Sorry, data is equal to 20, correct? Then sixth step, register 2. Okay, register 2 is equal to 20. Okay, seventh step, you know, uh, seventh step, then you have to add, na? So move, okay, move register 1 to combinational circuit. Okay, so then eighth is move register 2 content to combinational circuit. Okay, so then ninth one is perform, okay, perform operation, maybe in, it is adder, na? So add operation in combinational circuit. Okay, so after that 10th, you see, move result. Okay, move result. Okay, so that is 30 to register 3. Okay, registers 3. And then, there may be, some output lines may be there, IO lines. Okay, then 11th is move, okay, register 3 content to IO line. Okay, some IO line. Now, you see, step by step. So in this particular, to add two numbers, so this is how the, microcontroller takes instruction. So very simple thing what you have to understand. So in microcontroller or microprocessor, so states changes. Okay, every time the signals in a microcontroller microprocessor changes. Okay, signal in a microprocessor or microcontroller changes. Okay, so every change is happens after the clock pulse. You understood? So every change in the clock pulse, okay, so clock pulse, that particular operation happens. You see, so whenever clock pulse changes, the complete state of a microprocessor microcontroller changes from one state to other state. Now see, loading address is one state. So microcontroller or microprocessor is having some signals at every point. Then immediately when data becomes 10 and the state changes, you see. So whenever clock pulse triggered, so state changes, it moves from one point to other point. You see, it moves from one to other. Okay, so that is what you have to understand in any microcontroller microprocessor. What happens? You see, now uh, uh, now I just written 11 no, some kind of general what is the states, general state. Now to execute these things, it takes 11 clock pulses. It takes 11 clock pulses. So after executing 11 clock pulses, that addition of two numbers will be done. You understood? Okay, and you will get a result in IO port. You will get a result in IO port. Okay, so now that is what you have to understand in this particular example. Okay, any clarification you required in this? Internally what happens? Every movement, every operation, happens whenever you trigger clock pulse. You got it. Now the thing is, I have not told where this program is present. Okay, I have not told where this program is present. To execute this particular program, okay, so this is what happens. Okay, step by step. First, address will be loaded in address bus 01. That is one state. After next pulse, that data present in that particular address, that is 10, that will come to data bus. Okay, so that just reflects in data bus. And then after next pulse, that register data, whatever present in data bus will be loaded to register 1. Okay, so that is the next clock pulse, like this. So for every clock pulse, there will be some changes. Okay, so that is basically what is that? So this is addition of two number program. Addition of two number program. Okay, this program. Okay, so this program will be present in internal memory or external memory. Normally, the programs are present in external memory. Okay, so these programs are present in external memory. Okay, so I am telling where that program is present. So normally this is your microcontroller or microprocessor. Okay, so this program, this 11 steps are present in the external memory. So this is external memory. So there will be internal memory also. Okay, so there will be internal memory, there will be a combinational circuit. Okay, so this is the external memory. So this particular program, okay, so this particular program, this 11 steps is present in the external memory. Okay, external memory. And what you have to understand here, every microprocessor and microcontroller, okay, will have something called instruction decoder. Okay, instruction decoder. What is this instruction decoder comes? Whatever programs comes to the microprocessor or microcontroller, whatever program or instruction come from the memory. Okay, so this instruction decoder will tell what this combination circuit should do. You understood? What is the role of this instruction decoder? Instruction decoder, whatever instruction, okay, comes, okay, instruction come from the memory. Okay, it comes to the microprocessor or microcontroller, and this instruction decoder will tell what this combinational circuit should do. So if say for example, here you see loading address with 01, that is one kind of instruction. Loading data 10 in data bus, you see, moving register to combinational circuit, so performing addition operation. These are all different instruction. Okay, different types of instruction. How microcontroller understands? Because the instruction decoder will tell the microcontroller what it has to do. So when some instruction comes, so what microcontroller should do or microprocessor should do, that will be directed by this particular instruction decoder. So this is basically external memory. You see, ex- external memory will be there, and internal decoder will tell the microprocessor and microcontroller what it has to do. Okay, now say for example, now here first instruction is what? Address bus 01. Okay, so okay, address is equal to 01. So this is one instruction. When address is equal to 01 comes to the microprocessor or microcontroller, instruction decoder will tell microcontroller there is no operation. You just have to load the 01 in the address bus. Okay, so that will be taken care by this one instruction decoder. So that is basically the inbuilt program in microprocessor or microcontroller. That is how each microcontroller and microprocessor is differentiated. So every microprocessor and microcontroller will have their own instruction decoder. That means it has its own capability, right? So different microcontroller have different instructions. Okay, and that means advanced instructions and all those things. So all those things will be handled by the instruction decoder. Okay, so this is what you have to understand. So microcontroller, what we have to understand here. So in microcontroller and microprocessor, okay, so there will be a combinational circuit. So that receives the inputs and it solves and it gives the output. So for every change in the state, okay, so the every change in state in microprocessor or microcontroller is triggered by clock pulse. Okay, triggered by clock pulse. And microprocessor or microcontroller, you have to understand, step by step. Each single change is important in microcontroller. If you miss any single changes, you can't understand the microprocessor or microcontroller. You got it? Okay. So any any general questions, if you have any general question on this, you can ask. You can ask if you have any general question. Please do ask. See, normally whenever somebody teaches microprocessor and microcontroller, they will start with say by taking some microprocessor or microcontroller, they'll start with specification. Okay, so they'll start with the specification, architecture, and internal working of the microprocessor of that particular specific microcontroller. So now I'm just trying to convey how generally you have to understand this particular microcontroller and microprocessor, so that any microcontroller processor comes to you, you should be in a position to understand. Okay. And it's just a market trick that many microcontroller microprocessor, they'll use different terminologies. Okay, so that's why you should not uh, have any confusion. So that's why I'm just telling how internally this microcontroller microprocessor works. Okay, any questions, any questions, please do ask. Yeah, any questions? Okay, okay. So now So we understood that the program is can be stored in the external memory. Okay, and inside a microcontroller will be having some instruction decoder, and you'll be having some internal memories also there. Okay, definitely combinational circuit will be present in that particular microprocessor and microcontroller. Okay, so program will be fed from the external memories. Okay, so if you see your laptop. Okay, program is present in actually first your source code is present in the hard disk. From hard disk it will come to RAM. Okay, the program is present in RAM. Okay, so that is basically memory in your laptop, in your RAM. Okay, so from your RAM the program is present in RAM. That that instructions will come to micro processor, okay, of your laptop. So then there will be one instruction decoder in your microprocessor. So whatever instructions come from the RAM, so that instruction decoder will tell what it has to do. Okay, what this whether it is a simple data transfer, whether it is some addition operation, subtraction operation, division operation, what it has to do. Okay, what kind of instruction which is coming from the RAM. So that will be handled by this particular instruction decoder, and the microprocessor will solve that instruction. It gives appropriate output. Okay, appropriate output. So that is how this microprocessor and microcontroller works internally. Okay, so till now you understood whatever I told. Okay, so I'll go to that one more simple task. Now, last class I told you the bit, the microcontroller, the word length is one specification in the microcontroller. Okay, say now here you see 8 bit, 8-bit microcontroller, 8-bit microcontroller or microprocessor means. Okay, so you should be very clear. Your register size is 8-bit. Okay, your internal register size is 8-bit. And how many memory locations you can point? You can on a point 2 to the power of 8 memory locations. So 2 to the power of 8 memory locations means 2 to the 256 memory location you can point maximum. Okay, so 256 memory location means 0 to 250, 255. Okay, so this is in decimal. Normally we do not deal with the decimal. We deal with hexadecimal, 0 to ff. Okay, so this is x value. Okay, so that means your memory location will be from 00 to ff. You got it? So if you have 8-bit microcontroller, okay, or microprocessor, so total the pointable memory is 256 location. 256 location means the address will vary from 0 to ff. So your address will vary from 0 to ff. Similarly, let us consider if you have 16-bit okay microcontroller, microprocessor, 2 to the power of 16. Okay, so 2 to the power of 16 means 2 to the power of 6 into 2 to the power of 10. Okay, so 2 to the power of 6 means what? Okay, so 64. Okay, 6 to the power of 6 is 64. 2 to the power of 10 is kilo. Okay, so that means you can point 64 kilobytes. You see, 64 kilobytes of memory location. 64 kilobytes means 16-bit means 4 nibbles. Okay, 4 nibbles. That means 4 of you can point from 0 to okay some kind of 64 kilo. In decimal you can convert, it will land up in some number. So say in x value it is 0 to ff. So this is the range of the address. So range of the address what you can point with your address bus. You see, if you have a 8-bit microcontroller or 16-bit microcontroller, so this is the advantage if you have. So you can point more number of memories. If you have 8-bit microcontroller, only you can point 256 location, whereas here you can point 64 kilo. Okay, so kilo, this many numbers you can point if you have a 16-bit microcontroller or microprocessor. Okay, you are clear on this particular aspect. How many memory locations you can point now? So one more thing what you have to understand with respect to microcontroller or microprocessor. See, uh, in microprocessor or microcontroller, okay, so they won't have separate data bus and address bus. Okay, no separate data bus or address bus. I mean, very confusing statement. Okay, so microcontroller and microprocessor has no separate data bus and address bus. Okay, so they will utilize no. That means what? If you have a 32-bit or 64-bit system, I mean you should have 64 physical lines as a data bus, and you should have a 64 bits of address bus. So that means it becomes very bulky. Physically, it will become very bulky. So that's why they won't go for this kind of architecture. What they will do? Okay, so I already told if you have a 64-bit computer, so then what they will do, they will have one bus, so 64-bit bus. Then what they will do at some point, okay, so the same physical line, they'll use it as a address bus, okay, and data bus, okay. So they'll use it as an address bus as data bus. So that physical line will have a dual nature. Okay, so it is address bus as well as dual bus. So how it knows it is a address bus and dual bus? Again, I told you it's a clock pulse. Okay, so there is something called address latch enable signal in microcontroller. Address latch enable signal. This signal will differentiate basically whether that line is used as a address bus or data bus. Okay, so initially that will be considered as an address bus, then immediately that same physical line will become data bus. Okay, the same lines will become what is that data bus. Okay, so you understood this particular statement. In microcontroller and microprocessor, you don't have two separate data bus and address bus. Okay, so for understanding purpose, I told address bus and data bus in the beginning. Now what I'm telling, address bus and data bus both are same. Okay, sometime the same physical line will act as a address bus, and then it will become data bus. Okay, so then it will become data bus. So that is what I'm trying to tell. Okay, so now uh, any clarification you require, please do ask. If you have any, if you are confused, or if you need any clarity at this particular point. Okay, so now see, now the next concept is what is that? See, if you have a 8-bit microprocessor, okay, so 8-bit microcontroller or microprocessor. So the thing is, we know 2 to the power of 8 is the maximum memory location, that is 256 bytes. Okay, 256 bytes of memory. That means 250 locations. So 0, 0 to okay FF. This is the range of the address. Okay, range of the address. Now, what in all the microcontroller microprocessor they will do? Okay, so instead of this, okay, 8-bit address line. Okay, so if you have ideally what you should have, okay, if you have like this, then you should have like this kind of physical line. So that is 8-bit. Okay, So sometime it will be address bus and sometime it will be data bus. So ideally this is the thing. Now this won't happen in microcontroller or microprocessor. Now what they will do, so instead of you see I am coming in reverse direction, so they will have 16-bit address line, 16-bit physical line, 16 physical lines. You see, if you have 16 physical line, we are 16-bit. When you have a 16-bit, okay, how much memory location you can address? You can address 8-bit means 8 nibble, right? Okay, so 8 nibbles, 2 digit, correct? So if you have 16-bit, then that means 4 nibbles. That means you can point this much memory location. 64 kilobytes of memory location you can point. You see, okay. So this much memory locations you can have. To have this, what you should have? You should have to the power of 16. So that means 16 is 16. My microprocessor is not having 16-bit. What is that register? My microprocessor is having only 8-bit register. So to overcome this particular problem, what they will do? So first, in one first state, okay, first state, they will send say lower what is the 2 digit, okay, address will be having 4 digit, okay. So in first stage they load address line with lower 2 digit, okay, and in the second state, okay, they will load the higher uh, 2 digit, okay. So the next 2 digit they will place. So I mean that means that is how sometime it will hold what is that, from register it will take the first 2 digit and it will load it into this particular address line, and then it will go to the next register and it will fetch the next 2 digit value and it will place that particular address signals to the address line. In that way they will place the 16 bit address line in the physical line. You see, the register is 8-bit, but they are creating 16-bit address line. So register can hold only 8-bit information. Okay, address bus should load 16-bit information. Then how they are doing? They're one by one, 8-bit first. They will load that particular information to the address bus. Then they will load the next 8-bit to the other remaining lines. So that is how they are creating the 16-bit address line. And to load the data, what they have to do? They have to utilize only 8-bit information. That means they just have to use only 8 physical line. Okay, 8 physical line to handle data. Now what you have to understand at this particular point? So if you have 8-bit microcontroller or microprocessor, okay, so your data size is 8. Okay, your address, okay, so your address size is 16-bit. Okay, 16-bit. Your data size is 8-bit and your address size is 16-bit. Okay, data size is 8-bit and your address size is 16-bit. So anyway, this is depending upon the data size itself, this microcontroller is called as 8-bit microcontroller or not. So even though this microcontroller has 16-bit address line, so this is not called as a 16-bit microcontroller. This is called 8-bit microcontroller. So just to increase the range of memory, okay, so we are using this kind of architecture. So when I use 16-bit address line, then I can point more memory location. So that is the objective. So that's why to increase the memory location, okay, pointers. So then I am just using 16 physical lines instead of 8 physical line. Okay, 8 physical line. Okay, so this is the one thing which is actually implemented in all microcontroller. Okay, all microcontroller. Okay, so if you have 8-bit microcontroller, data size is 8 and address line is 16. If you have a 16-bit microcontroller or microprocessor, then your address line will be double, 32-bit. You understood? So that is how you have to understand this address bus and data bus. Now, in summary, data bus and address bus both are not different. That is physically same line. Okay. Address bus is normally double the value of data bus. Okay. Whatever the data bus size, that is the specification of your microcontroller or microprocessor. Okay. So you understood this particular part? Any questions? Any questions on this? Any questions? Okay. Okay. So you see here, I'm just giving a hint that even though this microcontroller or microprocessor is electronic subject, so whatever case studies, examples, programs I'll write, everything will be electrical domain programs and examples. So you won't find those things in anywhere. Okay, in any textbook you won't find that kind of program. So I told you now. So I may write a program, microcontroller program for relay. I may write a microcontroller program for to calculate energy. So this kind of program I'll write. So you normally won't find anywhere in any textbook. So that's why class is very important. Okay. So because all the questions I'll ask based on the class. Okay, whatever I delivered in the class, those things only I'll ask in the exam also. So that's why you have to be very attentive. Keep try to create a notes by your own. Keep one notebook beside you. Just accumulate these points, understand the concept, and just note down the points. And also in future, I'll be writing a lot of lengthy programs. Okay, so I'll write those programs in this particular whiteboard. You have to note down in your notebook. Okay, so that is very important. You otherwise you won't find anywhere. So I am not providing any notes. So this video itself will be the notes for you. Okay, so hope I am clear on this. So uh, so just you have to be attentive in the class, or you have to take this video and you have to carefully make your notes. Okay, so that you have to do from your end. Okay, so that's it for the day. Okay, if you have any question, stay back or you can join next class.